Welcome back to College Algebra. In this video, let's take a look at how we can find intercepts. All right. So whenever we're talking about x-intercept is where my graph cross over the x-axis. So let me draw it out for you real quick. So here, if I have an x and y axis, and here comes to my, let me use a linear function for example. Okay. Whenever my graph cross over the x-axis, that is called the x-intercept. All right, so x-intercept is where we're going to find x when the y is 0. Okay, so in order for us to find x-intercept, we're simply going to substitute 0 for x so we can find, 0 for y so we can find the x. The y-intercept is where the graph crosses over the y-axis. Okay, so that means I got to find the y value when the x is equal to 0. All right. Now I'm going to go ahead and talk about this now, okay, before I forget. When it comes to finding the x-intercepts, okay, it is actually a lot like finding the zeros of a function. We'll talk about the zero function in the near future, but the concept of x-intercept and the zero of the function is not quite exactly the same. All right, but the steps on how to find the zero of a function is just like the steps how to find x-intercepts. But the two topic, x-intercept versus the zero of a function, is actually not quite exactly the same thing. So we will talk, we have a whole entire, we got a lot of videos, it's actually that I will post regarding to what's zeros of a function, okay, in the near future. So for right now, okay, we're just trying to find the x-intercept. Once you get these steps down pat, then later on when we find the zero of a function, it will not be as difficult. All right, so let me help you make this transition, okay? So if I have a quadratic equation written in this form, remember quadratic equation is always set equal to 0. Quadratic function is always going to be f of x equal to like ax squared plus bx plus c form. If I put the two together, okay, it will be f of x equal to my quadratic function, but that equation part can also be equal to 0. So what's going on here is this part is the graphing part or the function part. From here to the equal to 0 is the equation. So if I put the two together, what we are saying is f of x, okay, if this f of x equal to this and this equal to 0, that means f of x is actually equal to 0. And remember now, f of x is just a replacement for y. So what we are saying here is y is equal to 0. Okay, so whenever we talk about the zero of a function, the number, the 0 is referring to y is 0. Your job is to find the x, which is the same concept, okay, which is a very similar concept, not the same, which is a very similar concept as finding the x-intercept, okay? So in order to find the x-intercept, we're going to set all our functions equal to 0. So the x-intercept we found can actually be considered as a 0 of a quadratic function, since we're talking about quadratic here. All right. So let's give it a try, okay? Let's give it a try. If I got this problem, okay, ax squared plus 10x minus 3 again. In the last video, I've done the graphing part. So let us find the x and the y-intercept. So let me do the y-intercept first. Y-intercept is easier. To find y-intercept, that means find y when x equal to 0. So I'm going to substitute 0 for x. So my y, input an x value, output a y value. So that'll be 8 times 0 squared plus 10 times 0 minus 3. So these two terms cancels out. So my answer would just be negative 3. Most of the students can figure out the y-intercept just by simply looking at the function, because every term contains x will all become 0. So the constant term at the very end tells us what the y-intercept is going to be. All right, now let's find the x-intercept. This problem is factorable. So I'm going to try to factor it. All right, find x when y equal to 0. So to find the x-intercept, we're going to set our function or set our quadratic function equal to 0. So that will be 0 equal to 8x squared plus 10x minus 3. I'm going to do this by factoring. I believe for the 8, I'm going to use 2 and 4. The 3 in the very end, I can only use 1 and 3. So if I put 1 here, 3 here, the outer is 6, the inner is 4. 6 and 4. All right, 6 and 4 will give me 10 in the middle if I add them. But since the last term is negative, I'm supposed to get to my middle term by subtracting. So this is not going to work. So I'm going to put my 1 here. I'm going to swap them. I'm going to put my 1 here and 3 here. Because now my outer is not going to be 2. My inner is 12. 12 and 2 combined will be 10 if I subtract. When the last term is a negative, the choice for the sign is 1 positive, 1 negative. Since my middle term is to be a positive 10, that means I need to give this positive to the bigger of the 2 inner and outer. So my 2 got to be negative. So since the 2 was an outer, that would be 2x times negative 1. This one got to be positive. All right, if I set each factor equal to 0, let me go ahead and just do this just by looking at it. If I set each factor equal to 0, 2x plus 3 equal to 0, I think x will equal to negative 3 over 2, right? Put the 3 over, divide both sides by 2. If I set 4x minus 1 equal to 0, I think the answer will be 1/4. Okay, move the negative 1 over, divide both sides by 4. All right, so got to write them as a coordinate form. So that will be negative 3 over 2, 0. The other x-intercept is 1/4, 0. All right. So normally when we're talking about the degree of the polynomial function or degree of the quadratic, the square tells me I should have at most, let me just say it this way. I should have 2 answers, at most 2 answers. So for right now, while we're talking about x-intercepts, I should have at most 2 answers, okay? Or 2 x-intercepts. So the word at most means, well, I can actually have less than that. So this problem kind of shows it. So by looking at it, I believe we can see the y-intercept is going to be 0, negative 1, just by plugging 0 for the x. So for the x-intercept, I believe this set by quadratic equation equal to 0. I believe this problem can be factored again, so that will be 3x and 3x, 1 and 1, and my, oh, didn't mean to put minus. Let's put a plus right here. Sorry about that. So in that case, 3 on the outer, 3 in the inner, both of these got to be negative. So my two factor are exactly the same. So once I set them equal to 0, x is equal to 1/3. So I actually have 2 answers. So but it's only 1 x-intercept because my 2 answers are exactly the same. Okay, my 2 answers are exactly the same. So I'm not going to write 2 of the same x-intercept. So I do have 2 answers, but since the 2 answers are exactly the same, that means I'll only have 1 x-intercept. All right, let's try this one right here. I think if I put a 0 here, if I want to find the y-intercept for this particular example, this one's a little bit different, okay? Gotta kind of figure this one out. Because if I put a 0 where the x is, that first term does not become 0. So I actually need to work it out. All right, so y-intercept, find y when x equal to 0. So let's give it a try. It's going to be f of 0 equal to 0 minus 2 whole thing squared plus 1. 0 minus 2 is negative 2. Negative 2 whole thing squared is 4. 4 plus 1 will be 5. So that's my y-intercept. So for the x-intercept, I'm going to find x when the y equal to 0. So I'm going to set my function y equal to 0. So that gives me x minus 2 whole thing squared plus 1. So this is only 2 terms on the right. So solving quadratic equation only consists of 2 terms. I can use the square root property. So I'm going to move my positive 1 over. So I will end up with x minus 2 whole thing squared equal to negative 1. When I take a square root on both sides, my answer should always be positive and negative. So here we go. X squared and square root cancels out. That gives me x minus 2. But the other side, square root of negative 1 is actually not a real number because it's an imaginary number. Okay. So when I move my 2 over, my x is actually equal to 2 plus minus I. So this is our complex number. The answer is actually a complex number, which is not a real number. Every time when we have answer that involving with an I, that's actually not a real number. So if it's not a real number, then I actually do not have the x-intercept. If you actually grab this particular function, you're going to see, just think about it though, what is the vertex? Without even graphing it in a graphing calculator, your vertex, x minus h plus k, right? Your h is 2, your k is 1. So that's actually to the right 2 up 1. This parabola, the leading coefficient is actually positive 1. So my parabola will actually open up. So that means this parabola actually never cross over the x-axis. That's why I don't have any. So what is this 2 plus minus I answer represent? They actually is the zeros of this function. They are not the x-intercept. They are actually the zeros of this function. Okay, so even though my quadratic function don't have any x-intercept, but it still have what? Have 2 zeros. So that's why up here I mentioned, okay, the concept of x-intercept and zeros is not quite exactly the same, because I can actually end up with a function that don't have any x-intercept, but I'm still gonna have what? Have my 2 zeros for the function. Okay, that will conclude this lecture video. Thank you for watching.